thick bands that join cells together, we have little tunnels called gap junctions. If the tunnels weren't there, then we'd have to have a cardiac autorhythmic cell basically stimulating each individual cell. This allows that wave of depolarization to spread from cell to cell to cell to cell. If they're attached via the little gap junctions, they're gonna depolarize if somebody else depolarizes. All right, differences between cardiac and skeletal. We mentioned cardiac can stimulate its own contraction. Skeletal, we have to have a neuron telling it to do it. We talked about the ions. All right, how does the conduction system, what's step one of the conduction system? Who's the pacemaker?
SA
node, and then from there we go to
AB
AB node, and then from there,
bundle of goods.
bundle, and then,
Left and
yeah, left and right, and then we're at the tip of the heart, where do we go?
Pug-G fibers.
Yep, there we go, and those go up that wall, yeah. Why do we need the AV node to delay the impulse? Why is SA inherently about 100, AV drops it to about 40? Why do we want the atria to contract before the ventricles? Yeah, to allow the ventricles to fill. If you had the whole entire heart squeezing, you'd just be gushing that blood out, right? You wouldn't have enough fluid to be pumping forward because all of it is squishing out. Okay, so EKG waves, what does P represent?
Atrial polarization.
Yes, and then QRS?
Ventricle depolarization.
Yes, and then T?
Ventricle repolarization.
Yeah. So when we say depolarization and repolarization, what happens after we have depolarization occur? What happens after step one and possibly two?
Contraction.
Contraction, right? So depolarization precedes contraction. Repolarization precedes what? Relaxation, right? Because relaxation is important because what happens during relaxation? Filling. If you're contracting, you're squeezing things out. So, all right, cardiac cycle. Initially, we are having blood return to the atria. So the atria are receiving blood, and then eventually, right, they start to contract, and then they squeeze blood through that AV valve into the ventricles. So the ventricles will start to fill. Then we have the ventricles start to contract after the atria contract. So there's a period of isovolumetric contraction where both of the valves, right, the semilunar and the AV valves are closed. And so once that contraction continues, that pressure builds up, what opens? AV or SL? Yeah, the SL, right? That pressure will push that blood forward. Think also contraction. Remember whenever we did the dissection, you see that the AV valves had the little tendae coordinae, and then they had the little papillary muscles. Those are contracting, they're pulling the AV valves closed. We don't want any backflow to go back into the atria. So contraction of the ventricles closes those AV valves. So the only way to go is forward, which is in the semilunar. So ventricles will eject that blood into the arteries, and then we have isovolumetric relaxation where it's going to be the same volume, and then the cycle repeats. Atria will start to receive blood, then they contract at the end to squeeze it into the ventricles, and so on and so forth. All right, so what is going to be higher, end systolic or end diastolic volume? So what does systolic mean and what does diastolic mean?
Systolic is contraction.
Yeah, so
Diastolic
systolic,
is
yeah.
reverse.
Yeah, there we go. So systolic thinks squeezed, right? So what do you think is going to be higher? The end squeeze volume or end volume after you've squeezed? Or the end volume after you relaxed? Which is the diastolic.
Is it when you squeeze anymore?
The volume in the
no,
heart.
when it relaxes. It's
Yeah, there we go. Because when it relaxes is when we fill. So end diastolic volume, you're relaxed, you're receiving blood. after you contract, when you're contracting, you squeeze that blood out. So systolic is gonna be the lower amount. So stroke volume refers to what? The name says what it is.
The end diastolic ventricles minus the What?
Yeah. So that's the exact formula. So the end diastolic, which is the relaxed amount, minus the end systolic after you squeezed them out, after you squeezed it out amount. So stroke volume. Huh? Yeah. Stroke volume is the volume the blood pumps out with each stroke. So yes, there's an amount of blood left after you've relaxed and after you've squeezed. So this will give you the amount that you've pumped out. So that formula is correct, but stroke volume is the amount with each squeeze or each stroke of the heart. Cardiac output, that's the amount your heart puts out in a minute. What's the two guys that come into that? So your heart rate is per minute. What other guy plays it?
stroke volume.
Yeah, heart rate and stroke volume. So the amount that your heart puts out in a minute is correlated to the rate, the heart rate, and the volume, the stroke volume. Okay, all right, so we'll move